Okay, so this is where we left off. Last time we were doing this example, we did part 1, where we found the angle between these two planes given by these two equations, but we haven't yet done part 2. We haven't found the equation of their line of intersection between these two planes. The last thing I said yesterday was that the line of intersection between two planes, I'll abbreviate that LOI for line of intersection between two planes. That line has to be orthogonal to both of the normal vectors. Any normal vector of the first plane and any normal vector of the second plane. And so one way that we can get a vector that's orthogonal to both of these is to take the cross product. So this cross product, N1 cross N2, is going to be orthogonal to both N1 and N2. That's just one of our properties of the cross product. And so then that means this is going to give us the direction of that line of intersection. And after we know the direction of the line of intersection, the only other thing we need to know is one point along the line of intersection. And to get a point on the line of intersection, that point has to belong to both of these planes if it's going to be a point at their intersection. And so what I'll do to find that point is I'm going to go ahead and write x minus 3y plus z plus 5 equals 0. And below that I'll write 2x plus 3y minus 2z minus 1 equals 0. And what I'm going to do is called elimination. I'm just going to add the first equation to the second equation and see what I get. So x plus 2x is going to give me 3x. Negative 3y plus 3y is going to make that y variable disappear. That's why this is called elimination. And then z minus 2z is going to be minus z. And then 5 minus 1 is going to be plus 4 equals 0. So I can rearrange this, and what I can say is x plus 4, now let me say it this way, x plus 12 over 3 is equal to z. Hey George. So in that step, what I just did is I added z to both sides of my equation to get the z on the right side. And then I said, let me divide both sides by 3. So that actually should be z over 3. And then, oops. So I've made some mistakes. I tried to do everything too fast. Let me just rewrite this one step at a time. Maybe I'll get rid of all my mistakes here. So then I want to divide everything by 3, and I get x plus 4/3 equals z over 3. Yeah, that's way different from what I had before. But that's actually correct. Anyways, this is kind of like what we did a while back. I don't know how many days ago. This is kind of like a symmetric, I think we maybe did this yesterday, a symmetric equation for a line. And I haven't yet figured out what my y is going to be. What I can do to figure out what y is going to be is I can just maybe substitute. And so I'll take this equation for this plane, but I'm going to replace x with z over 3 minus 4 over 3. So instead of having 2 times x, I have 2 times z over 3 minus 4 over 3 plus 3y minus 2z minus 1 equals 0. And so this is going to give me 2/3 z minus 8/3 plus 3y minus 2z minus 1 equals 0. So that would be like minus 11/3 for my constant plus 3y minus 2z minus 2/3 would be 4/3, I think. 4/3 z equals 0. I think I just collected all my like terms. And I'm trying to solve for y, and so what I'll say is 3y is equal to 4/3 z plus 11/3. And finally, y is going to be equal to 4/9 z plus 11/9. Something like that. So I've got that, I've got this. I'm going to rearrange this and say x is equal to z over 3 minus 4 over 3. Something like that. Okay, so just by doing old algebra tricks, stuff you learned in your algebra class a long time ago, what we've been able to do is find this equation, which gives me my x-coordinate explicitly as a function of my z-coordinate right here. And then I also have an equation that gives me my y-coordinate explicitly as a function of my z-coordinate, right? So if you just give me any old value for z, z could be 0 or 42 or negative 500, you can give me any value you want for z, and I will tell you the corresponding x and y values of a point that lie on this line of intersection between these two planes. Okay. So now if I just choose a z value, and for me, I'm just going to choose the easiest z value. I'm just going to choose z equals 0. I can get my x value is going to be negative 4/3, again according to that equation. And then my y value is going to be 11/3. No, take it back. My y value will be 11/9 according to this equation. And that means this point has to lie on my line of intersection, and so the point negative 4/3, comma 11/9, comma 0. This point is on my line of intersection. Okay, now I know the direction should be this cross product. I actually need to find this cross product if I haven't already. Yeah, I still need to find this cross product. And this is going to be the cross product between 1, negative 3, 1, and 2, 3, negative 2. Just make sure I copied those correctly. Yep. Okay. So in this cross product, I have to find the determinant of this matrix. And I keep calling this a matrix This is not technically a matrix because a matrix would have entries that are all just scalars. In a matrix, all the entries are just numbers. But remember, I, j, and k are representing our standard unit vectors. And so those are not numbers. And so that makes this not a matrix. And so it's not really a determinant. This is just more like a good calculation trick. It happens to work exactly the same way you would normally take a determinant, so that's why we do this. But we're taking the determinant of this pretend kind of matrix thing. So that will be I times the determinant of this minus j times the determinant of this plus k times the determinant of this. So I'm going to move kind of quick because I want to keep going and I want to make through it. I want to make it through the next section as well. But this is going to be positive 6 minus 3 is 3. Negative 2 minus 2 is negative 4. And then 3 minus negative 6 is going to be 9. So this line of intersection is going to be in the same direction as this vector, 3, 4, 9. And since it's in the direction of this vector, I can use the entries of this vector to be those coefficients a, b, c in my parametric equation for a line. So now that I have a point, x naught, y naught, z naught, that belongs to the line, and I have the coefficients a, b, and c. Remember, my parametric equation for a line should look something like x naught plus at, comma comma y naught plus bt, comma z naught plus ct. So here's the answer to my problem. It's going to be negative 4/3 plus 3t, comma 11 over 9 plus 4t, comma 0 plus 9t. And that's it.